All right. Couple things about the final before we start. The calculators you need will be linked at my website for it, so you'll have access to those calculators. Standard deviation and the binomial probability distribution calculator. I believe those are the only two that we've been using them. You're allowed one sheet of paper. I will give you a brand new Z table and T table for the test. So you have one sheet, you can use both sides of the paper. The test will be next Monday. I will be here at 1 o'clock. So you can get here as early as 1 o'clock to start it. And you'll have till 4:30. You do not need all that time, but you have all that time. So if you can get here early, you can get here early and start. If you have a class before this one, you can get here on time and have time afterwards. So you have plenty of time to be able to do the test in that respect. It'll be on Hawks, same as the other ones. I will let everybody know by Wednesday. I'm just going to finish up the grading on the last tests tomorrow. I will let you know on Wednesday if you're exempt from the final. Do remember, though, to be exempt, you have to have all the homework completed as well. So you need a 90 or above on all three tests and all the homework completed. So the final exam can replace the lowest test grade that you have. So if you do better on the final exam than one of your tests, it will replace the lowest test grade to improve your grade. All right. Any other questions about that? Yes.
When you say exam, do you mean like you safely skip it?
Yes, you will not have to take it. You literally, you have an A in the class, you're done. So yes, you'll not have to take the final at all. I will let you know on Wednesday. Any other questions? All right, then let's start going through the review. Mean, mode, median. What's mean? Yeah. Average. Add up all the tests, add up all the numbers, and divide. There's no other easier way to do this one, just adding them all up and dividing. Yes.
Is it calculator for this one, right?
No, actually there was just a you just use your calculator for this one, really. Yeah. I'm just moving my calculator so I can actually see the numbers while I'm typing. Yeah, there's because like I could give you a calculator to do it. The only difference, but you're still gonna have to type all the numbers in, so it's not really makes much difference. And we had 1, 2, 3, 4, 1, 2, 3, 20. So I got 0.541. Okay, good. I typed my numbers correctly. Yeah, I was gonna say, okay, good. I typed my numbers in correctly. Yeah.
That's the one you can put in Excel, right?
Yeah, if you put it in Excel, like you can do, like that's fine. Yeah, there's a few different ways you can do it. Like, but again, it's like you're still gonna physically have to type the numbers in, no matter which way you end up doing it. So that is your mean. Median. What's median? Middle number. So this one you have to put them in order. So, or you don't really have to put them on R, you can kind of cross them out. We have 20 numbers, so we're looking for, so in this case, my middle number is not actually going to be the middle number, it's going to be the two middle numbers, correct? I'm going to take the two middle numbers, add them up, and divide by 2. So let's cross off the bottom 10. So we've got,
Does this have to be in order?
yes, but like I said, you kind of can like figure out which the bottom ones are. So 2, 9, 30, 31, 32, 33, 34, 35. I think the next one's 41. 3, 4, 5, 6, 7, 8, 9. So that's a middle number. I don't think any of the other ones are smaller. And if we go the other direction, looks like 73 is the highest. So 1, 2, 3, 4, 5, 6, 7. I must have crossed off one. 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I crossed off 10 of those. That's why. So that one, and then a 50. Yeah. So 0.52 plus 0.50 is 1.02 divided by 2 is 0.51. That's your median. And mode is the most often, which I think is 0.5. Yeah. So 0.50 appeared 3 times. I think that's the only one that appears 3 times. 0.61 appears twice. Yeah. So
if there's like
yeah, so if you could, if we had 2 of them that appeared 3 times, we would have 2 modes. You could actually have a bunch of modes, like that's possible. So it's whatever one appears the most often, and any ones that appear the same number of times as that. So if the 0.61 appeared another time, like say like the 71 right there was 0.61 right there, then they both would have been modes, and I would have had 2 modes. There is a possibility if they all appear the exact same number of times, there is no mode. So if they all appear once, there's no mode. If they all appear twice, there's actually no mode for that either. All right, standard deviation. This is the one you're using the calculator for. You do still have to actually type the numbers into it, however. So this is the calculator for it. So you type the numbers in. It's going to ask you if it's population or sample. It will tell you in the problem. Sample to standard deviation. So this will be a sample. So make sure you use that sample option there. So 98. Apparently I screwed this up. Okay, and apparently I have 22 numbers I typed in for some reason. Oh, that, no, 98, 98.3.
Oh, okay. I was gonna say, isn't there like a copy data thing?
Yeah, I can't do that though, unfortunately. All right, I'm not going to figure out where mine is right now. It's way too much time. That's okay. This is not the answer because I have 22 numbers and I know there's only 20. So somehow I typed in the number twice. But the key is when you're doing this, when you're typing it in, make sure you use sample, not population. It will give you your standard deviation at the top. It will also tell you your mean, but it won't tell you your median or mode. So you could technically use the calculator to find mean as well. As long as you type them all in correctly. All right. Question of the standard deviation? Okay. All right. Next one. So, oh, I didn't switch over. This one. All right, so it says the number of hours per week that the television is turned on is determined for each family in a sample. The mean of the sample is 35 hours, the median is 31.2. 24 of the families in the sample turn on the TV for 20 hours or less. The 12th percentile of the data is 20 hours. So the question is based on the information given, is the following statement true or false? The 55th percentile is greater than or equal to 30 hours. So what do we know? Yeah.
We know the mean of the data.
We know the mean of the data. Okay. Okay. So which one are how are those going to help me figure out about the 55th percentile?
Average of everything, so,
Okay.
oh, I was thinking, what's the word? Bimodal, like yes or no.
Oh, okay.
So
Binomial,
I
yeah.
had in my head that it was 50, but then. Yeah,
Gotcha.
no.
So what's percentile mean? Going back. What's the 50th percentile? Okay. What's another name for the middle? Median is the middle. Mean is not necessarily the middle. Okay, that's the average of all the data. And if you have outlier or numbers on either end, you can skew the mean. But the median is the middle number. So percentile is telling you how many numbers are before it, how many numbers are after it, not necessarily where that is in terms of like the average. So your median, so I know my median is 50th percentile, and that's 31.2. So it says the 55th percentile is greater than or equal to 30 hours. So if my median is 50% and that's 31.2, what's a possible number for the 55th percentile?
above 31.2?
It would have to be bigger than 31.2, right? We don't know what the number is. There's nothing in this information that gives me the exact number. All I do know is that that number has to be greater than 31.2 because 55 is higher than 50, correct? Okay, so this statement is true. Because I know it's greater than or equal to 31.2, so therefore it's greater than or equal to 30. Does that make sense? Again, remember this goes back to that English thing, right? It's like how it's worded and how it's stated. I know for a fact that the number is greater than 31.2, therefore it has to be greater than or equal to 30. Okay? So that statement is true. Yes.
So just to double check, you're saying because the median is higher than the 30 it gave, anything above the median would also be higher?
Right.
Okay.
Yeah, exactly that. Okay. So like they gave us a whole bunch of other information in here that we don't necessarily need. All right. Same question or same data, different question. Approximately how many families are in the sample? So now we need to start using some of that other information. So what information did they give me that could possibly help me figure out how many people are in the sample or families are in the sample? Yes.
It's the 24 families in the sample, right?
Yep. So there's 24. Well, is there only 24 families in the whole sample? No. Okay, so I know a 24 turn it around for less than 20 hours. What else do I know about 20 hours? Does it tell me anything else about 20 hours? Yeah. Yeah. Good. That's the 12th percentile. So I know that there's going to be 24 families that are less than the 12%, right? So 24 families equals that 12%. Because remember, percentiles is breaking down how many families or how many people are in each percent, right? So if I have 24 families in 12%, we can do this a couple different ways. 12% of some number equals 24. So how do I solve that? Yeah.
It would be 0.12x equals 24.
Yep. And then we would divide.
Equal it out, right?
Yep. Divide by the 0.12. So x equals what? What's 24 divided by 0.12? Yes. There is another way you could have done this one because this number works out kind of nice. What's 24 divided by 2? 12. 2, right? So that means every percent is 2 people, or 2 families. So the 1th percentile, there's 2 families. 2 percentile, there's 4 families. So 100 percentile, there'd be 200 families. So because the 24 divided by 12 works out really, really nicely, you could have actually done it that way as well. So we have 200 families. All right. Next question.
Same information again.
Yep, same information. This is one of those multi-part questions. So approximately 100 families turned on their television for less than 35 hours. So what do we know?
We know roughly how many families were in the study?
Okay, so we know 200 families, based on the last data, we found out there was 200 families in the study, right? So 200 families total. So 100 families would be what? Right, so 100 families would be the 50th percentile, right? Okay. So is the 50th percentile 35 hours? What did we determine in the first part of this question? What's the 50th percentile? It's 31.2. The 50th percentile is the median, not the mean. So this statement is false. If it had said more than 100 families turn on their television for less than 35 hours, yeah, that would be true. But since it says approximately 100 families, that means they're looking at basically looking at 100 families. And this question is purely to make sure you understand the difference between mean and median in terms of percentile. Yes.
This doesn't have anything to do with the continuity correction stuff, right?
No. That's binomial.
Oh, right.
What's the value of the 50th percentile? We've only said this one twice already. What's the value of the 50th percentile? 31.2. It's the median. Based on the given information determines the following statement is true. The first quartile is less than 20 hours. So what is the first quartile? So what was the 5-number summary? Because this obviously can be asked a few different ways. What was the 5-number summary? There's 5 specific numbers we were looking at. It was that wonderful when we started looking at like the box and whisker plot. What's this one right here? What would the value for that be? Think about this for a second. But the furthest you can get on a set of data is. I would say it starts with M, but there's a ton of stuff that starts with M. What's the lowest you can possibly go? What's another word for that? Minimum. This would be the what? That'd be the max. Good. The middle is your median. That is your 50th percentile. It is also known as your second quartile. So this would be my first quartile, and that would be my third quartile. So if the second quartile is 50%, what's the first quartile going to be? 25%. And the third quartile would be 75%. So the first quartile is less than 20 hours. What do we know about the 20 hours? Yeah. Right. The 12th percentile is 20 hours, right? So by definition, the first quartile has to be what? Bigger than that, right? Because it's 25%. So the first quartile cannot be less than 20 hours. So this statement is false. Any other questions with those? Before we go on to a different problem. Yeah.
I assume there will be ones where it doesn't give us the like nice. Does it give us the median every time? Or-
Yeah. Because the one part of this question is literally designed to get you to figure out if you're talking about median or mean.
Right.
So they will always, the data they're going to give you is very similar to that.
Okay.
So, like the numbers might be slightly different, but they're going to give you the same basic types of data. So. And my guess is 24, that type of number will still be written out because they want you to actually read the problem and not just look for numbers. Yeah.
Also, what do we do if it's not like easy? Like, for example, with the 12th percentile being 20 hours, and then asking is the first quarter less than 20 hours? Like, will it always be like that, or will it give us like a strange?
Well, it could be like the first one where they told you like they could have said the 30th percentile of the data is 20 hours. And then that statement would have been true.
Right.
Because the first quartile is going to be less than the 20 hours. Kind of like the first question that we did, where it said the 55th percentile is greater than or equal to 30. It's kind of like that type of situation. They could do something like that. That is possible. Yeah.
So would like the best way to do this be like the box and whisker plot, and then just
And just like, yeah, like you're logically trying to figure out which direction it's going. That's kind of like what we did with this one. Was it this one? Yeah. We were saying the median I know is at 50. So I know that 55 has to be bigger than 50. So if 55 is over here, that means that has to be greater. So that has to be true. It had to be greater than 31.2. So that same kind of concept there. So yes, all those are a possibility. All right. Pizza delivery company classifies customers by gender and location. They've gathered data from a random sample of 1,727 customers. The data is summarized in the table below. All right. What is the probability that a customer is either customer is female and lives in an apartment, or is male and lives in other? So we've got two separate probabilities here. So let's look at the first one first. Let's look at female and lives in an apartment. So what is the probability that they're female and lives in an apartment? Yes.
Was that the sum of all the female things and then divided by 77?
No, okay. So there's two different types of problems. So this one, so you're looking at give the one that they say given this. So if it says what's the probability that they're a customer is female given they live in an apartment, that's when we're going to look at those individual columns or rows. This one's just female and lives in an apartment. So it's the intersection of those two things. So in this case, it is just the 77. So it's the 77 out of the 1,727. So it's out of the whole thing because they didn't say given that. That's that word that if they say given, then you start to think about, okay, I've already know this. What's the probability that this is going to happen? I think there's one of those coming up in a minute anyway. Never mind. Maybe not. Maybe not. Can't remember if I put one of those on there or not. And now we have the other one. So we have male and lives in other. So that would be the 173. So that's 173 over 1727. So the answer would be the combination of both of those. We were going to add those together. That's what the OR is. So 250. And you can leave it as a fraction. I might not have one on here, so I'll do this one with this one. All right, what's the probability of a customer being male given it's a fraternity?
Out of all the males, right?
So what's the given? Right. So we're looking at this row. That's the given. So that's the bottom number. So we would add up those two. And that's going to be my bottom number. So when the given is going to be your bottom number. So in this case, my given is 194. And then how many males? How many males out of those two? 73. So the answer would be 73 out of 194. If we want to go with English, the answer is 100%. Because males are in fraternities and females are in sororities. But based on the question, the answer is 73 out of 194. Does that answer the question about givens? So the givens, so like if I had done it the other direction, if I said, given that it's male, what's the probability that they were in a fraternity? I would have added up all the males, and that number would have been down the bottom.
Okay, but because you're saying,
I said I gave you fraternities, and then I'm asking for male. So what I'm asking for is on the top, what you're given is on the bottom. Okay. All right, so let's keep a jar, change the desk. Current jar contains 18 pennies, 19 dimes, da, 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 da. What is the probability that you reach into the jar and randomly grab a dime and then, without replacement, a penny? So what is the probability that I will randomly reach in the jar and grab a dime? So what are the two numbers that I need? Yes.
is it how many dimes and just the total?
Yep, exactly. Yep. So I have 19 dimes. And what's the total?
Right.
20, 38, 39, and 34, 73. So that's the dimes. So the next question, the next part of this says, and then without replacement, a penny. So what's the next fraction going to be? 18 out of 72. Because we did not replace the penny, so I've got one less in the, we didn't replace the dime, so I got one less in the jar. So it's 18 out of 72. And that's the probability of getting the penny. So 19 out of 73 times 18 out of 72. There's it as a decimal. If you press the button, it gives it to you as a nice little fraction. So 19 out of 292. If it didn't say, if it said with replacement, we would have put the dime back. The only change would have been the bottom would have been 73. That'd have been the only change in it. If we were picking a dime both times, it actually would have been the exact same answer. Because I would have removed one from both. I'd have only had 18 dimes left in the jar instead of 19 dimes. So I'd have subtracted one from both. Doctor visits her patients during morning rounds. In how many ways can the doctors visit 6 patients during the morning rounds?
Is it the 6 factorial one?
Yes, actually it is. That's exactly what it is. So how many patients can I visit first? 6. How many patients are left for the next one? 5. How many patients are left for the next one? And the next one, and the next one, and the next one. So you multiply those. Let's see, 120 times 6, which is 720. So there's 720 different ways. Yes.
That's the factor is the same things like the 6 with the exclamation point.
Yeah. The other way you can actually do it is permutations. It's 6 choose 6. Because order does not matter. Or sorry, order matters. That P is order matters. So NPR is order matters. NCR, order doesn't matter. So in this case, since they're different ways, the order matters. So it'd be NPR. They both come out to be 720 though. All right, so what do we got in this problem? Real estate agent has 10 properties that she shows. She feels there's a 50% chance of selling any one property during a week. The chance of selling any one property is independent of selling another property. Compute the probability of selling no more than 6 properties in 1 week. So what type of problem is this? Go ahead.
Is it binomial?
Yes. Why is it binomial?
True or false? They either buy it or they don't.
Right. You either sell or not sell, right? So it's there's a one or the other option. So this is a binomial probability. So this is the one we're going to use the binomial distribution calculator. That's this calculator right here. So for this problem, there was a 50% chance. She has 10 properties, so the N is 10, and she wants 6 successes. So you get those numbers. The question is which one do we want? So it says probability of selling no more than 6 properties in a week. So which one of those 5 options is no more than 6? Well, which ones can we eliminate?
I think we can eliminate the greater than ones, right?
Yeah, because that would be greater than that, right? So we can eliminate those 2. So I know it's not that one and that one. I also know it's not the equal one. So it's got to be one of the less ones. So the question is it less than or equal to? Is 6 no more than 6? Yeah, 6 is no more than 6, right? No more would be 7, 8, 9, right? So 6 is no more. So if 6 works, that means it's the equal to one. Okay, so that's the answer. And they want it rounded to 4 decimal places, so it'd be 0.8281 would be the final answer. So you eliminate off the 3 at the end. Yes.
I only really knew that decimal is.
That's okay. No more or less than
Wording always.
Oh, yeah. Yes. Yeah, they like to do that in a whole bunch of different ways there, that question. So so the question is do you understand how to read this problem, realize it's binomial? That's going to be the biggest thing, because if you can't identify it's binomial, then you're not even going to know where to start. So the key is that they say that the selling of the properties are independent of another one, so there's no overlap between it. They're independent. And that there's only 2 outcomes. You either sell it or you don't sell it. The 50% there, that doesn't matter. That could have been anything. So just because it was 50% does not mean it's a binomial. It just means there's a 50% chance of selling. So that could have been 10%, and the problem would have been no different. The only change that would have been made was when we looked here, I would have changed that to 10%. So 1. So that would have been the only difference in that respect. Where was it? There it is. And also, because I know they've done it in some other questions, make sure to read that they're looking at the same thing. So it says the probability of selling, it says the chance of selling, it doesn't say the probability of not selling, like that type of switch. It can happen, so just be careful on the direction or the wording that they use in it. All right, this is an expected value problem. So the bet is that you'll draw 2 cards without replacement from a standard deck. If both cards are clubs, your friend will pay you $531. Otherwise, you have to pay your friend $32. So we have 2. So we have 2 clubs. Is 531, and then anything else is minus 32. So the question is what is the probability that you're going to get 2 clubs? All right, so what's the probability that you're going to get 1 club?
13 out of 52.
13 out of 52. It says without replacement. So that means how many clubs are left in the deck? And how many cards are left in the deck? 51. So Dendos comes up to 1 out of 17. So what's the probability that I'm going to get anything else? Or what's the probability I'm going to lose? Yeah. Yeah, 16 out of 17. Remember, all your odds have to add up to 1. So 2 clubs is 1 out of 17. The opposite, the complement to that would be 16 out of 17. How do I find expected value? Yes.
Average?
So, yes, but this is a weighted average.
Oh, right.
So remember, when we're looking at weighted averages, the averages, we have to multiply and then add them together, and then you divide by how many you have in this case. So in this case, I'm literally just going to multiply by how many times those things would come up. So the 531 times the 1 over 17 plus negative 32 times 16 over 17. And that would give me my expected value. So my expected value, since this is in terms of money, you round it 2 decimal places, is $1.12. Questions with that one? The one key piece to this is make sure you set your losses to a negative, because otherwise it'll totally give you the wrong answer. Is this a fair game? By definition, a fair game, your expected value is 0. That means you never win or never lose.
Will that come up?
Well, I just can't remember if I actually ever told you that. Yeah, by definition, it would be 0. Huh?
Yeah.
I might
So
have.
it's ever so slightly in our favor?
Yeah, so in this case, if you play it enough, you're gonna win. Like the odds, you're gonna win technically. The expected value basically tells you how much you'd expect to win on every hand. So, but now you can sit there and play 17 hands, you'd expect to win 1 of them. You're gonna expect to lose 16 of them. But if you did that, you'd walk away with probably about an extra $17. So any casino game, the expected value is negative because they want to make money. All right.
Oh.
Yeah.
What about the,
This is the
you
last
had
one.
some situations that, from that unit where you said you have to pay this much to play and then?
Yeah, so if that's not going to be on the test. That would be like, so in this case, if I'm paying $5 to play, yeah, my expected value would be lower. All right. If you played the same time, if you played this game, this is the same question, same information. So we had, what was it, $1.12? I think we figured it out. Yeah. And this will be the last question of the day. We're making this bet 524 times. So that is for one bet. If I'm doing that 524 times, we would multiply that by 524 times. And I'm not doing that in my head. $586.88. So we would make $586.88 if we played this game 524 times. Okay, any other questions with that? All right, so we will do, because all the rest of the questions are related to the Z tables and stuff. So we will do we'll do those on Wednesday because it's a nice break between the probability and stuff. So you're welcome. The review test is in Hawks now. So you can do the review test. This final exam review. So okay. I will see you on Wednesday. Yes.
You know, I'm thinking you have to